All right, this is day 5 of our Unit 1 statistics, and we're going to continue with our concepts. You pretty much have done, learned about standard deviation, learned about mean. You've learned how to find the mean and the mode and the variance and the median. And you've learned how to figure out percents with normal probability. So you've had lots of practice. So now we're moving on to something called z-scores. All right. Z-scores are values that show how many standard deviations. Let me write that word. Show how many standard deviations a data value is from the mean. Okay. Now we've been practicing normal probability. So we have done 1 standard deviation, 2 standard deviation, 3 standard deviations, but sometimes it's not that exact. So we have to figure out what the z-score is and what it represents if it's not exactly 1 standard deviation or 2 or 3. Okay, it could be in between. It could be 2.33. So that's what we need to figure out. When the z-score is positive, the data value is above the mean. All right, and we kind of talked about that yesterday too. In our bell curve, it is greater than the mean. When the z-score is negative, that the data value is below or less than the mean. So z-scores can be positive or negative, okay? When a z-score is 0, then it is equal to the mean, okay? It is equal to the mean. Now, you're going to have a formula that's going to help you calculate z-scores. And that formula is the z-score is equal to some data value minus the mean divided by the standard deviation. So that is the formula that we are going to use. Okay? Now, a few little things as we go to calculate. All right, you guys have that in front of you. I'm going to move up. So z-scores are decimals. Z-scores are decimals. All right, and we are going to calculate z-scores 2 decimal places. That means to the nearest hundredth. So 2 decimal places to the nearest hundredth. Okay. All right. So I'm going to write our formula down here because I don't have it above. Is some data value minus the mean divided by the standard deviation. Okay. All right. So let's start with this first problem. A radar detector records the speeds of a group of cars that pass by. If the mean is 46 miles per hour and the standard deviation is 2.8, I need you to find the z-scores. So that means we're just plugging in numbers right now. So this number that I'm giving you is your data value. Okay, that is your data value. In other words, your x in the formula. So z equals x, which is 52, minus your mean of 46, divided by your standard deviation of 2.8. Put that in your calculator, and you get 2.14. Okay, that's your z-score, 2.14. That means it is a little bit bigger than 2 standard deviations from the mean on the positive side. All right, let's try the next one, 42. So 42 is my data value, or x. So my z equals 42 minus my mean of 46 divided by 2.8. And my answer is negative 1.43. This means it is a little bit bigger than 1 standard deviation, but it is below the mean. okay? So it's between 1 and 2 standard deviations below the mean on the left side of the mean, okay? 47, let's do this one. So my z equals 47 minus the mean divided by the standard deviation, and you get 0.36. So it's just a little bit bigger on the positive side of the mean. So it's between the mean, which is 0, and 1 standard deviation. Okay, so it's important that we understand what a z-score represents. All right, let's look at number 2. Now we're finally getting into a real-world problem here. Not that these were not. Okay, these were too, but maybe we're not. Maybe we have to find other parts of this formula. So the mean of total miles ran last week by each member on the track team was 4. So I'm going to come over here and I'm going to write the mean is 4. Okay. Standard deviation is 1.2. If Clay's z-score, oh, they give us the z-score this time, is 2.5. Okay. I need to know how many miles did he run. This is my x or data value. Okay. All right. So using my formula over here, I know the z is 2.5 equals, I do not know my data value, that's what we're trying to find, minus my mean divided by my standard deviation. All right, we got to solve for x. So let me get some colors out here. I'm going to change this one to red. All right. How do I get rid of my denominator? I am going to multiply both sides by 1.2. That means those cancel. Then I'm going to multiply these. Let me write that word here. And 1.2 times 2.5 is 3. So I get 3 equals x minus 4. Now we're solving for x. I'm going to add 4 to both sides, and I get x equals 7. Now I found my answer, 7 miles. Okay, so now we're practicing our algebra. We're practicing where do we put numbers, and we're practicing our algebra. Let's move on to the next one. Using that same formula, okay? A set of test papers is normally distributed. Now I'm going to say that because this is where we have the bell curve, and this is when we use these z-scores. With a standard deviation, so here we go, standard deviation is 5. If Riley's score, this is my x, this is my data value. If Riley scored an 83 with a z-score of negative 0.4, well, what is the mean? So let's use our formula and plug what we have. So the z-score is negative 0.4 equals, our data value is 83 minus the mean, because we don't know it, divided by our standard deviation of 5. Okay, solving for the mean this time. So multiply both sides by 5. Those cancel. Multiply 5 times negative 0.4, and you get negative 2 equals 83 minus the mean. All right, I'm going to subtract 83 from both sides because we're solving for the mean. And I get negative 85 equals negative mean divided by negative 1. So I know my mean is 85. So my average of test papers, okay, is 85. All right, let's try another one. I'm going to keep working these. The heights of a group of trees is normally distributed with a mean, let me write this down, a mean of 14.3. Oh, I'm going to go back to green. If the z-score for a 20-foot tree, oh, hold on a minute. So let's first figure this one out. Wait a minute. The z-score is 1.9. Now, my data value, we're talking about a 20-foot tree. I need to find the standard deviation. Don't know it. Question mark. All right, we're going to use our formula again. So my z is 1.9 equals, my x is 20 minus my mean divided by my standard deviation. Now, anytime you have an unknown by itself on the bottom and a single number over here on the left, you may just switch places. All right? And if you were in class, I showed you why you can do that. Okay? I guess I could show you real quick. Let's show you real quick. So if I have 1.9 equals 20 minus 14.3 divided by standard deviation, we would multiply standard deviation on both sides. So now we have 1.9 times standard deviation equals 20 minus 14.3. Well, I want this all alone, so I'm going to divide by 1.9. That means I'm going to divide by 1.9. So I end up with standard deviation equals 20 minus 14.3 divided by 1.9. Now look, I told you could just switch those two places. So if I switch them, I get standard deviation equals 20 minus 14.3 over 1.9. Look, both the same. Okay? But again, you can only do it if there's this one variable. It's kind of like a variable or unknown on the denominator and a single number on the other side of the equal sign. Okay? So I could do all this work and I will end up the same place. So you pick what's more comfortable for you. All right, this just goes into your calculator and you get your standard deviation is 3. And there's our answer. Okay? All right, so we're going to go on to the next part of our classwork that we're doing in class today in the next video.